Okay, welcome back. Continuing this series of spring break learning. Hopefully we can learn some things. Today we're going to talk about the outer planets and their moons. Maybe this will be a two-parter, the outer planets part 1 and the outer planets part 2. It's because there's a lot of information here. The inner planets discussion was posted earlier. I would recommend watching that if you haven't, and so we can continue on this discussion. The outer planets, let's get into it. So the asteroid belt is kind of the marker between the inner solar system and the outer solar system. The asteroid belt is between Jupiter and Mars, and it is just a whole bunch of chunks of rock. If you want to learn about that sometime later, there's a lot of other videos and so forth, or you could ask me to do one about it. I don't know, whatever. So there are 4 planets beyond the asteroid belt. They are Jupiter, Saturn, this is Uranus, and this is Neptune. These 4 planets are similar-ish, just like the terrestrial planets are similar to each other, but they are all different from one another in many ways. And we'll talk about those different ways. Jupiter is the largest, most massive of the planets, followed by Saturn. And then Uranus and Neptune are pretty similar. So let's get into it. They are all gigantic. They're much, much larger than the inner planets. So when we talk about Mercury and Mars and then Venus and Earth are big-ish, right? I mean, Earth is huge compared to us that live on its surface. However, when we compare these little planets to the outer planets, they are truly tiny. Uranus, Neptune, and then Saturn and Jupiter are kind of in a class of their own. They are humongous, and we call them the gas giants or ice giants. The ice giants, we mostly are referring to Uranus and Neptune, and the gas giants are Jupiter and Saturn. They all have a set of rings. Some of them are very, very small and thin. All of those rings are shredded remnants of a moon that got too close and then just got torn apart. So the first is Jupiter, and we have the symbol for Jupiter here. Jupiter, this is supposed to be like a lightning bolt. I don't know exactly what this symbol is precisely. It looks like a very strange 2 with a 1 on the end. I don't know. Or like some people think it looks like a 4. But Jupiter is the most massive and largest of the planets in our solar system. It is 317 Earth masses. So it is 317 times the stuff of Earth, and it is primarily hydrogen, which is the lightest element in the universe, but there's a whole crap ton of it. It takes 4,332 Earth days, or 11 years, to go around the sun once. So every 11 years on Earth is 1 year on Jupiter. It rotates very quickly, especially for how large it is. It only has to go, it only takes 9.5 hours to go around once. Pretty impressive. And it is 1,321 times the volume of Earth. So in terms of how much space it actually occupies, how much space there is inside of it, 1,300 times that of Earth, while it is only 317 Earth masses. So that means that there's a lot less stuff per cubic meter, right? So it's much less dense than Earth, but it is much, much larger. And there's just a whole bunch of stuff. It has a very, very strong magnetic field, and we can talk about that in just a second. So it is huge, all right? Jupiter is the Roman god of lightning and thunder. So when we talk about that, the Greek equivalent is Zeus, and the Norse equivalent is Thor. And so the day of the week that is named after Jupiter is Thor's Day or Thursday. So Thursday is named after Jupiter. The god of lightning. The inner workings of Jupiter, so it has a huge amount of pressure, right? Because it's so massive, there's a lot of stuff, all that stuff is pushing in on itself, and this actually creates a form of hydrogen called metallic hydrogen, and this metallic hydrogen is very, very conductive to electricity. So we have a very strong magnetic field, and this creates a magnetosphere that pulls in a whole bunch of ions and creates this, the aurora on Jupiter. So here on Earth, we have the northern lights and the southern lights, the aurora borealis and the aurora australis, the northern and southern lights. Jupiter has the same thing, the northern and southern lights, and we can see the northern lights of Jupiter right here. It has very, very strong magnetic field that pulls in all of these ions that interact with the atmosphere and therefore make this beautiful blue light show. So metallic hydrogen is something that we cannot reproduce here on Earth because it takes way too much pressure. The only way that we can possibly do something similar is by squeezing hydrogen in between plates of diamond. But we can't quite reproduce it. It just takes way too much pressure. So metallic hydrogen creates a very strong magnetic field, which pulls in these ions from the sun and creates the aurora borealis or the aurora australis, the aurorae, as they say in plural, for Jupiter. All right. Magnetic field. It has a very, very strong magnetic field. In fact, its magnetic field is so strong that just the radiation of going through its magnetic field would probably kill you in just a few hours. Very, very, very strong magnetic forces. But you didn't know that magnetism can kill you. It can. Because it traps some radiation in between the magnetic lines. So if you were ever to try to go to Jupiter, you would need to have some serious radiation shielding, maybe some lead or a whole bunch of water to protect you from all that radiation. Jupiter has enormous storms, and we can see each one of these circles are gigantic storms, and most of them are much larger than the Earth. Because Jupiter is so large, it doesn't really give us a whole bunch of perspective on how large these storms are, but they are gigantic. We can see that this rapid rotation and the inner heat make this very tumultuous atmosphere. And Jupiter is essentially just atmosphere. It's just a whole bunch of gas. There is something that you would kind of consider solid, but at that point it'd be so low and so hot and so pressurized. It's more like a superfluid. So when people say that there's not really a solid surface on Jupiter, they're correct. But some people say that you could fly right through Jupiter, which you couldn't. It's not solid. It's more of like a superfluid, but at that point, it's just kind of crazy and difficult to wrap our heads around. The Great Red Spot, which is right here, you can see, is the largest of the storms on Jupiter. It is about 3 times the width of the planet Earth. It's been going for at least 300 years. But there are many, many more storms. These are real pictures, by the way, that I have in this slideshow. I always try and use real pictures because I think that they're much more interesting. These came from a spacecraft called Juno, which is currently going around Jupiter, taking all these really cool pictures. You can see these amazing storms here in the cloud tops of Jupiter. All right, and you can see this banded nature of the cloud tops. The darker clouds are going one direction, the lighter clouds are going another, and they're actually at different altitudes in the atmosphere. I'm not going to get into why they are different colors, but just know that they are going in different directions. And then you can see here that at the poles, so this is one of the poles here, it is more of a blue color, while the equatorial or tropical regions are more brownish red with white clouds as well. This blue is actually methane, and this is the same stuff that gives Uranus and Neptune their blue color. So Jupiter has a gazillion moons. I believe that the current count is 79 confirmed moons. We'll talk about 4 of them. They're called the Galilean moons, of course, named after Galileo Galilei, who was the first one to observe them through a telescope, which is really cool. If you ever have the opportunity to look at Jupiter through a telescope, chances are you will see one or all 4 of the Galilean moons. Both of these moons are larger than the planet Mercury. They are very, very massive in comparison to other moons in the solar system, really because Jupiter is massive in and of itself. Jupiter is kind of like its own solar system. It has a whole bunch of stuff going around it, and 2 of those things are the moons Ganymede and Callisto. Here is Ganymede, here is Callisto. They're heavily cratered. They might have some liquid water under the surface. I mean, they are very, very cool to look at. And if you have the chance to look through a telescope, you'll probably see one of these 2. Io. Io is really interesting. It is the closest of the moons of Jupiter. It orbits so close, in fact, that Jupiter's gravity squeezes and pulls and twists the interior of Io and makes it very, very hot. It creates these volcanic plumes. So all of these scars that you see here on Io's surface are volcanoes, and they are active volcanoes. And this blue smudge here looks just like a blue smudge, but it is actually an erupting volcano on the surface of Io. And this is the ash and dust erupting out of that volcano, being caught by the light from the sun and illuminating it. Very cool. Io is not a place that I would really like to visit. It's constantly erupting with volcanoes and pretty crazy place. It is a very, very tumultuous area of the solar system. Io. All right. So Io is the most volcanically active body in the solar system because the heat from the stretching and pulling from the gravity of Jupiter. Io is just far enough away that it didn't get pulled into a set of rings around Jupiter. And then, in my personal opinion, the coolest and most important of the moons of Jupiter, this is Europa. Europa is covered completely in water ice. This is water ice here. So these are like gigantic icebergs all connected together, and you can see these cracks in the surface ice. These cracks every once in a while spew out geysers of liquid water. So we know that the tidal forces that heat Io also heat Europa, and therefore there is heat underneath the surface of Europa from the pulling and stretching from Jupiter's gravity, and therefore it keeps some of the water that is on Europa liquid and not solid. So we know that there is more water in the oceans of Europa than there are in the oceans of Earth. Isn't that crazy? There's more water on Europa than there is on Earth. And that's liquid water. I'm not talking about frozen water. I'm talking about liquid water. There's more liquid water on Europa than Earth. And so these huge, thick oceans underneath a crust of ice could have life. We don't know. Someday we'd like to go and maybe fly through a couple of these geysers and give them a little taste, see what's in there, see if there's anything swimming around under the surface of Europa. We are sending a mission called Europa Clipper, and hopefully in the next decade, in the next 10 years, to fly through the plumes, the geyser plumes of Europa, and see if we can find anything alive. So in the past, we've sent many, many missions. This is Juno here, the one that is currently orbiting around Jupiter. Pioneers 10 and 11, Voyagers 1 and 2, Galileo, Juno, and then Europa Clipper. Set to launch sometime in 2020s. I think that right now the launch date is like 2026, something like that. I won't talk too much about the rest of that. Saturn. I think that we'll cover Saturn and then leave it there, and then you can look for my video on Uranus and Neptune on a different day. Saturn is really the crown jewel of the solar system. It is beautiful. If you've ever seen it through a telescope, you know what I'm talking about. You can see the rings. The rings are extremely impressive. Jupiter has a set of rings, but they're really thin. They're not visible through a telescope. Saturn, this one's pretty easy. You can probably guess what day of the week is named after Saturn. That is Saturday. So Saturn, and then of course Monday and Sunday, moon and sun. So that's the 7 days. So if you watch the Inner Planets video, Sunday is the sun, Monday is the moon, right? Tuesday is Tyr, which is Mars. Wednesday is Mercury, or Odin's day, right? Tyr's day, Tuesday. Odin's day, Wednesday, which is Mercury. Then Thursday is Thor's day, which is Jupiter. And then Friday is Freya's day, or Venus. And then Saturday, which is Saturn. So that rounds out the week, the days of the week. Pretty cool. I think that's very interesting how astronomy has impacted our culture in the past. So 95 Earth masses and 763 Earth volumes. So that means that there's some stuff, but it's really spread out. In fact, it is less dense than water. So if you had a swimming pool the size of a planet, a very large planet, you could float Saturn in that swimming pool. It takes 29 Earth years for Saturn to go around the sun once, and only 11 hours for it to spin on its axis. It is beautiful to look at, and once again, we see the aurora on Saturn, an indicator of a magnetic field. There's a hexagon, which is super interesting, at the northern and southern poles of Saturn. It is a wind and storm pattern created by the spin of the planet. Very interesting. Creates this hexagon shape. It's primarily hydrogen, has some helium, but again, it is very, very light. It is less dense than water. The rotation rate is kind of a guess. We don't really know. It's very difficult because its magnetic pole and its rotational pole are exactly lined up. Most of the time, they're kind of off from each other, and so you can tell how fast it spins. Because there's no surface to see, and the clouds are always moving and so forth, it's kind of difficult to guess. So we have it down to 11 hours. We're pretty sure that's very, very accurate, but we don't have a very precise rate. It has aurora, like I just said. But let's get to what everyone wants to talk about, which is the rings. Saturn has beautiful rings. They're really, really wide, 70,000 kilometers. So if you were to go to the innermost ring, which is right here, to the outermost ring, which is out here, that's 70,000 kilometers, which is much wider than the planet Earth. However, they're very thin. They're only 10 meters thick. So 10 meters is like the height of a normal house. So it's wider than Earth, much, much wider than Earth, and only as tall as a house. That's pretty crazy. They're very thin, and they're primarily made out of ice. A little bit of dust, but mostly ice, like water ice. They're named A through F, and then there is a large division. You can see it in the shadow here. This is actually the shadow of the rings on the planet. Pretty cool. That is called the Cassini division, which is an area of the ring that is completely empty. Very cool. The rings are beautiful. Again, they're primarily made out of ice, and they are not all, they're not consistent. They're all little pieces, and we'll talk about that in just a second. Saturn has 62 categorized moons. 53 of them have names. They differ greatly in size, but only 13 of those moons have a diameter greater than 50 kilometers. Most of its moons are very small. They do vary in coolness as well, let's be honest. there are, if you want to look at this image, I want you to look at this image and determine how many moons you see in this image. So this is the ring. The planet is not in this picture. The planet is somewhere off of the frame here. I'll give you a hint. There's one in the background there that's very obvious. How many other moons do you see here? So there are 4 moons in this picture. This is the largest of the moons in the background. This is Titan. This is one of its moons called Enceladus. And then there is this moon here, itty bitty little tiny guy. I believe this is Pan. And this is Iapetus, one of the moons. So there are 4 moons in this picture. And some of them keep the rings all nicely lined up. They're called shepherd moons. They use their gravitational force. It's very small because they're tiny, but they use the gravitational force just to make sure that those rings are in the same right spot. It's not like they're doing that consciously. It's just how the gravitational pull works. And they keep Saturn's rings nice and tidy. They can make very interesting disturbance patterns. You can see this here. Very cool little disturbance pattern from one of the shepherd moons because of its gravity as it goes around the planet. So this is what I wanted to talk about. There are millions, billions of tiny particles going around Saturn, and these particles make up the rings. Some of them are the size of a grain of sand. Some of them are the size of a car. However, where do we draw the line between a ring particle and a moon? Because technically they're all moons, right? A moon is just a natural satellite, a natural piece of rock going around something. And they're all going around. So they're little tiny things going around the planet. Should we consider them all should we consider them all moons? Should we just consider anything that's in the ring as a ring particle, even some of these moons? I believe this is Pan, which is a shepherd moon that goes in between the rings. Something to think about. Should we consider all of the particles moons? Should we consider only the bigger ones? Where do we draw that line? All right, Titan. Titan is the largest of the moons around Saturn. It has mountains, it has lakes, it has oceans, but that ocean is not made out of water. That ocean is made out of methane or ethane, which is a hydrocarbon. It's the same stuff that comes out of a natural gas stove. So if you cook with gas at your house, you turn on the stove, ethane or propane, that is the same stuff that is liquid on the surface of Titan. It has a thick atmosphere, which has these orange clouds. It's crazy cold. Liquid methane on the surface. Liquid methane on the surface of Titan. And it has rivers and snows and rains. It has a liquid cycle, just like we have the water cycle here, but instead of water, it is methane. Very cool. Most of the surface features, like the mountains and valleys, are actually made out of water ice, but they're hard as rock because it's so cold. It's so cold there because it's so far away from the sun. Really, really far away from the sun. And then Enceladus. So we talked about Europa earlier, that moon of Jupiter that has really thick oceans underneath a crust of ice. Europa is very similar to one of the moons of Saturn called Enceladus. And Enceladus, again, is covered in water ice. It's very white. This is a beautiful image. I love how white it is with these blue stripes. They call these the tiger stripes. And these are areas where geysers of water shoot out. And this moon, it's very small. It's very, very small. It's much smaller than our moon. Smaller than the dwarf planet Pluto. However, it has a whole bunch of water. Very low gravity. And so it shoots these geysers, and those geysers will go way out into space. And they can go so far out that it creates actually another one of the rings around Saturn. made of ice that has been spewed out from Enceladus. So again, it is heated by the tidal forces of the gravity pulling and pulling and pushing and twisting on the interior of the moon. However, it has just less of that heat. So most of it's frozen, but we think that there is still liquid water. And we know that there's liquid water. We just don't know exactly how much there is. Very cool. Enceladus is one of my very, very favorites in terms of the bodies in the solar system. It would be an amazing place to go visit. Just imagine a perfectly white landscape with a horizon that was very, very close. Because the moon is so small, you would see the horizon as being very close to you. And then in the distance, you might see geysers of water shooting up into the sky. And then, but what would be really cool is to look up and see the rings of Saturn, and then Saturn itself just dominating the sky. It would be huge in the sky. Be a beautiful place to visit. Same with Europa. Europa would be very cool to visit as well, because same deal. Jupiter would be huge, and you could see so much of it. It'd be really cool. So there's have been several missions to Saturn. This is the Cassini-Huygens mission. It is one of the coolest missions in history, in my personal opinion. Went to Saturn, took a whole bunch of pictures. In fact, all the pictures of Saturn that we looked at, including its moons, all of these pictures came from Cassini. Really cool spacecraft. It burned up in the atmosphere of Saturn intentionally a few years ago. Beautiful. I would highly recommend, if you want to watch a YouTube video about it, check out the JPL video called Cassini Grand Finale. Check it out. And then it also put a lander on Titan called Huygens that took some pictures as it went through the atmosphere of Titan. Really cool stuff. So that's where I'm going to end it. Hopefully you learned something. I just want you to think about how small you are and how amazing it is that we know so much about these amazing planets. This blue dot in this image is Earth. Here's Saturn. You can see it is a dark ring here. The sun is behind the planet, and then you can see the rings of Saturn. This really, really bright one, actually, is that ring that I was talking about, formed by Enceladus. This is Earth. And we are so, so small, and yet we have been able to do so many amazing things, truly amazing things, sending these spacecraft out to these planets that are hundreds of millions of kilometers or billions of kilometers away from us, that we've been able to take pictures close up, do measurements of their magnetic fields and how fast they spin and their moons and what it is that they are. It's amazing that we, these little tiny things on this little speck of rock, have been able to do such incredible things. And I hope that inspires you. I hope that that makes you feel alive. I hope that that makes you feel like we can do amazing things, because we can, and I know that you can. And I hope that you've learned something. And we will return to learn more together at a later date. You're all awesome. I will talk to you later. Have a good rest of your spring break.